Today's topic is regression and its applications. So, regression meaning it is the functional relationship between the two variables, and of the two variables, one may represent cause and the other may represent the effect. Okay, so the one is dependent and the other one is independent here. Okay, the one is going to represent the cause and the other may represent the effect. Okay, so the cause effect is dependent on the cause. Okay, so the variable representing cause is known as independent variable um, independent variable and denoted by x, and the variable x is also known as predictor variable or repressor. Okay, so the variable representing effect is known as dependent variable and it is denoted by y. Y is also known as predictable variable. So it also predicts something. The cause also predicts us, something, and the variable also predicts us something. Okay, but the one is dependent on the independent variable. Okay, so the only one is independent and one is dependent variable, depending on which we are going to analyze the status or the relationship between the two variables here, that might be x and y. Okay, so the relationship between the dependent and the independent variable may be expressed as a function, and such functional relationship is termed as regression. That is what is today's topic. Okay, so the relationship between these two terms is what is regression. Okay, so when there are only two variables, the functional relationship is known as simple regression, and if the relationship or the relation between the two variables is a straight line, I is known as a simple linear regression. When there are more than two variables and one of the variable is dependent upon the others, the functional relationship is known as the multiple regression. Okay, so this regression or the regression line is of the form of y is equal to a plus bx. If I tell this formula, I hope you people recollect some little things in your lower classes. Maybe in the 9th and 10th, I remember in the geometry, you would draw a straight line graph and you would find the variable of y when x is given, right? Do you remember that? So that is what is going to apply here as a regression here. Okay, so the formula that they give, and they give the variables for x, you would have to find the y and then plot the graph in your lower classes, isn't it? The same thing is here, that is named here as the regression. The value of a and b can be calculated by using the method of least squares, and alternate method of calculating the values of a and b are by using the formula. The regression equation of y on x is given by y is equal to a plus bx. The regression coefficient of y on x is given by, so the y value, the x value, when you're going to find out, you have that the coefficient of the x and y can be given by the formula b is equal to the sum of xy minus sum of x sum of y the whole divided by n, the completely divided by the sum of x square minus sigma x square but divided by n. So and a is equal to y mean y bar minus bx bar. Okay, so and you would also see the regression line indicates the average value of the dependent variable y associated with the particular value of independent variable x. So here is that what it indicates, the average value of the dependent variable, that is y, associated with a particular value of an independent variable. That's what we are trying to explain you from the beginning, right? The one is dependent and the other was independent variable. So here is a graph which shows you how the dependent variable and the independent variable is. Independent variable is referred as x, or nothing but the cause, and the dependent variable is nothing but the effect, that what we see. Okay, depending on the uh, independent variables, we have the dots, that is data points which we have. Okay, after which, after getting the data points, we are going to analyze and try to get a relationship between the x and y by drawing a straight line. If possible, how many points are going to coincide with each other. Okay, so we are not going to try to set up the points there. Whatever the data is there, we are going to place the dots there. Then the dots are joined by a straight line. Okay, if a straight line is drawn, how many dots are coming into that particular region here? Say like 1 2 3 4 5 6 7 and 8. Maximum of 8 values are coinciding with a straight line. That means this line is a line of regression which shows us how linearly the cause and effects are moving together. Okay, the cause is directly proportional to the effect which we are seeing, that is the dependent variable, that is y. Okay, so here is a statistical data, again the same thing, but here you can see normalized daily earnings for a story. Okay, and normalized daily member reading time for a story. So this is an application based graph to show you how it can be applicable. Okay, so normalized daily earnings versus member reading the time. Okay, member reading time. So here is the application wherein how long time a person could read that particular daily earnings. Okay, so this is the graph which shows us a little slanting way, which in which there are around 2 3 4 five dots are coinciding with each other, which shows us the r is nothing but r square is equal to 0.879 as the regression value. Now what that value says and what is its uses? See, the uses of the regression analysis, it is useful for the analysis of, useful in predicting the value of one variable from the given value of the another variable. So one value can be predicted by the given value, isn't it? The x used to be given and we used to predict it, or we used to get the value and then plot a graph, right? We can even predict this might be the value of the other one. Okay, so when you know the cause, you would already know, if at all you have experienced the effect, then you would already know what might be the effect, isn't it? The predicted effects can be predicted, analyzed. Such prediction are useful when it is very difficult or expensive to measure the dependent variable y. Okay, so the other uses of the regression analysis is to find out the causal relationship between the variables. Then suppose the manipulate the variable of x, then obtain a significant regression y on the variable x. So next, thus we can say that there is a causal relationship between the variable x and y. The causal relationship between this nitrogen control of soil might be calculated, and growth rate in the plants can be calculated, and or the dose on an insecticide and molarity of the insect population. mortality, that is the birth rate, mortality of the insect population, and also maybe established in this way. You could give many other reasons of the cause and the effect. You can plot a graph and say how effective the cause is. Okay, so you can make a plots like that of all the cause and effects, which shows you the regression values there. Okay, so how and all it might be useful. See, before that, I've already shown you the graphs, isn't it? See how the values, the causes has relationship between the effect. So the cause is directly proportional to the effect, that you could see it, so that the regression is very much positive here. Okay, so biochemical and chemical assay development, pharmacological response over the time, stability predictions can be given, concentrations of the drug versus the time, how well the drug can affect the person with what particular time, or how long time it is going to take up to get affected on a person. Study of dose response relationship, fitting linear portions of pharmacokinetics data, best fit to linear physiochemical relationships, calibration of analytical data, plot of assay recover versus the known amount. Okay, and it is also used in the enzyme kinetics also. Okay, so here ends up the topic of the regression. If you have understood, and if you have any doubts, you can have in comment section there. So if you have liked it, please like the video and subscribe for it. Okay, see you soon with the next video. Thank you.